Alright, so this is just a little bit of help with the the paraprofessional test. So let's take a look at this. So the square root of 20. So all the square root does is basically when you have, let's say, the prime factor of 9. Let me get down to a decent brush size. Well, we know that 9 is 3 times 3, right? And so I know that the square root of 9 would just be equal to 3, right? So it just means one of these guys, right? So what I always tell my students is that these two fight to get out of the house, and one of them makes it out, right? Whoop, there he is. Right? So we have to take a look at the square root of 20. This is going to be a little bit more complicated. So let's look at the square root of 20. Let's break it down to its prime factorization. Well, not its prime factorization, but let's factor it a little bit. I know that 20 is 4 times 5. I know that 4 is a perfect square, right? 4 is 2 times 2. So what's going to happen here is that the 2 is going to come out, and that's 2 times the square root of 5. Now the square root of 5 is a number. The square root of 5 is a number between, oops, let's try this again. Square root of 5, it's about 2.2. So let's round it down to 2. So it's approximately going to be 2 times 2-ish. It's going to be a little bit more than 4. So we'd say it's between 4 and 5, right? In reality, if we plug it into our calculator, we get about 4.47. So that's a number between 4 and 5. So what is 120 million in scientific notation? Well, one way that you can kind of think about this is we're just kind of getting rid of all these zeros, but they're not really going away. We're going to put our decimal point right there. So it's going to be 1.2, but then we kind of have to account for all those zeros somehow. So we have 1, 2, 3, 4, 5, 6, 7, and then we actually move the decimal right there, so 8. So there's kind of that decimal is 8 places away from where it would be normally at the end of the number. So 1.2 times 10 to the 8 power. So it should be B. This one's B as well. Number 3, write the following as an equation. What is the product when x is multiplied by 5? That is just x times 5, right? So we use this little dot for multiplication, right? Typically we would really say 5x. That's really what it looks like, but this is technically correct. So 3 B's so far. So use the information below to answer questions 5 and 6. The prices for 5 speakers are as follows. $45, $41, $38, $50, and $50. I don't see a question here. I'm assuming it's going to be what's the mean or the average, right? So the average is simple. It's probably the hardest one, but we would add all these numbers up. So add all these numbers up. And we're going to divide all these numbers by 1, 2, 3, 4, 5, because there are 5 numbers in total. So let's throw that into our calculator. So that was 45 plus 41 plus 38 plus 50 plus 50 comes out to 224. And then let's divide that by 5. We get 44.8. That's how we find the mean. Remember, this was 44.8. Oops, sorry. 8. The median, it's a little bit weird. This one's going to be easy because we have an odd number of values. So let's start by putting it in order first. So median, you always need to start by putting it in order. So from lowest to highest, it's 38, then 41, then 45, then 50, and 50. This one's easy to see. It's just the middle value, 45 right here. So we'll say A. With a larger data set, you might want to start by kind of whittling down to the middle, like that. It's not too bad. Pretty simple, right? Where this gets harder is just pretend for a minute. Pretend that this was an even number of values. So suppose that it was 45 plus, I'm just going to make up numbers, 48 plus 49 plus 50. I'm so silly. Sorry, not plus. So just suppose it was like that. We would actually have to find the middle value here, and we would find what's in between 48 and 49. But like I said, the median's pretty simple when it's an odd number of values, like it is here. The mode is easy. Think of the mode as which one happens the most, right? So clearly we can see that there's two 50s, right? So that one's pretty simple. So these ones are kind of just a memorization game. It's a little bit difficult, but it's not too bad. So let's find the next few. Let me zoom out a little bit more. Okay, so these are scatter plots. Useful for analyzing a relationship between two variables. Here we can clearly see what we would call a positive association, and all that means is that this would be our x variable, this would be our y variable. We can clearly see as we move from left to right? So as x is increasing, or the color of the shirt in this case, we also see that these values are moving up. So I always move from left to right as this variable, whatever it is, as the color increases. We can also see that our values are moving up there. Our y values are also going up. So as the color of the shirt increases, the man's happiness also increases. Okay. That's what a negative would look like this. Right? That's what a negative correlation would look like. Right? So not super difficult. A bag contains 10 green M&Ms, 12 blue M&Ms, 8 red, and 3 brown. What is the probability that an M&M chosen at random will be brown? So this is going to be desired over total. Let me zoom in a little bit more. Desired over total. Okay. So our desired in this case is brown. Right, it's asking how many will be brown, right? And we still just need to find our total, but our total is easy to find. We can just add all these numbers up. 10 plus 12 is 22, 22 plus 8 is 30, and 30 plus 3 is 33. So that goes in the denominator. And then if we're asking, well, how many of these will be brown? There are 3 brown, right? So let me get rid of all these other ones because we're only interested in that 3. That's 3 over 33, and you might be saying, well, wait a minute, I don't see this in the any of our answers. We need to simplify this fraction. Remember, 3 is a prime number. 33 you can think of as 3 times 11. These two cancel out, so we got 1 over 11. That is our answer. A. So let's solve for x. This inequality, this is only really a problem if we have negatives, and I don't see any negative numbers in here, so let's just solve this almost as if it was a regular equality. There's a few tricks we could do, to be totally honest with you, but we won't really need them for this one. This is just a regular two-step equation. So let's subtract 9 from both sides. We want to get that x by itself, right? 9 minus 9, that cancels out. The 3x comes down. 18 minus 9 is 9. And now, what's the opposite of times 3? Divide by 3. So we'll divide 3 by both sides. These 3's cancel out. I'm left with x on the left-hand side. 9 divided by 3 is simply 3. Except we're not using equalities, right? This is an inequality. So, in this case, x would be greater than 3. Okay, not too bad. 1 millimeter would be 1,000th of a meter. Just metric conversions, milli being a prefix for 1,000, I believe. I think in Greek or Latin, right? Just think of a millimeter as being really small, right? A centimeter is, of course, 100th of a meter. Right. Centa, like century. Cent, like century, right? So a centimeter, I think 100, 100th. Of course, this is what we would call our distractor, right? Probably the most common mistake. Oh, this is interesting. If y is any odd number, which one of the following is true about y plus 1? There's a lot of number theory I could do about this one, but why don't we start by looking at a couple of just random use cases. Maybe just choose some random numbers. So like 3. I need some more space. Let me zoom over here a little bit. So suppose maybe here's my y, and then y plus 1 will be over here. So I'm just making a table. We're just going to do a couple cases, and you'll see my point. Y plus 1 in this case would be an even number. It's going to be even. So let me show you why. Let me show you why. So let's just make some random odd numbers. 3, 19. I'll just do 27, and let's choose a big one. 503. Whatever. It's totally random. Just made them up. So if y is one of these odd numbers, well, let's look. Y plus 1 is 4. In this case, 19 plus 1 is 20. 27 plus 1 is 28. 503 plus 1 is 504. You see that these are all odd numbers, obviously, right? Think of it this way. Think of we know that any even number, let's say some even number, some number k. It would be 2 times any number, right? We know that any even number, meaning that k is even, right? Right. Okay, so this is kind of working backwards, but if k is an even number, it's a multiple of 2, right? So I know that 2 obviously is even. 4, 6, that's 2 times 3, 2 times 4, 2 times 5, 2 times 6, and so on, right? Forever and ever. All right, well, let's add 1 to both sides. Well, k plus 1 is odd, right? So same thing, right? If k was 2, well then k plus 1 would be 3. odd number. 4. If k was 4, then k plus 1 would obviously be 5. If k was 6, 2 times 3, right? And k plus 1 would be 7, and so on, right? Forever. I kind of did it backwards, but it still works. So in this case, if y is an odd number, y plus 1 would always be an even number. It looks a lot trickier than you think, right? I'm going to tell you the answer is A. And if you think about it, well, what is the difference between a triangle and any of these three shapes? Well, these three shapes are what we call quadrilaterals. Right? Quad meaning 4. 4 sides, 4 corners, right? Obviously, a triangle has only 3 corners. I can't make a rectangle with only 3 corners, right? So if you wanted to, you could, I suppose, make a quick graph, but it's kind of a waste of time, isn't it? When we know that a triangle is the only shape that possibly could have these 3 vertices, right? 3 vertices, not 4. So number 14 looks pretty challenging. Using the figure below, if the largest possible circle is removed from a 10 by 10 foot square, approximately how many square feet are left? I get the feeling this is going to be an area problem. My main hint is square feet, right? When you think about the square footage of a living room or whatever, we typically describe it as having so many square feet, right? So if all 4 sides, I should say, of the square are 10, well, I know that the area of the square is going to be length times width, 10 times 10, which is 100, right? So our total is 100 square feet. This one's going to be a little bit challenging. We have to think about the largest possible circle, right? We have to think about the largest possible circle. So if this is, stay with me here, this one's going to be a little bit challenging. We kind of have to think about a radius, right? So if I'm looking at the center of this circle, and this is 10 feet long, right? Well, what's half of that? It'd be 5 and 5, would it not? If I split that in half, that'd be 5 and 5. Meaning that the length from here to here would be 5. This is going to be my radius. So we've deduced that my radius r of the circle is 5. Okay? This is all we need to find the area of the circle that's being cut out. So that is the largest possible circle that can be removed, right? That can inscribed within this square. So let's find the area of the circle. Right? I know that the area of the circle is pi times r squared. We know that r is 5. I should fix that. Not r squared. We know that r, not r squared, is 5, right? So let's replace that value. Pi times 5 squared, right? We know that 5 squared is just 5 times 5. We know that 5 times 5 is 25. So 25 pi. So think of it this way. We have a circle that has 100 square feet. right? This white circle that has an area of 25 pi. Right, so let's get a decent it's going to be an ugly number. Let's get a decent approximation for 25 pi, because what we're going to do is we're going to do 100 minus 25 pi, right? We are removing, right? So how do we find what's left? How do we find this black region? We subtract the area of the white circle from the area of the square, okay? 100 minus 25 pi. So like I said, we need to find a decent approximation of 25 times pi, 78.53. We'll call it 70. We'll call it 79. We'll call it 79. So we'll say 25 pi is approximately 79-ish, right? So say approximately right here. That's the wavy equal sign. 100 minus 79-ish, right? We'll do 100 minus 79. I'm just too lazy to do the math. It's 21. It's 21 feet. I'm a typical mathematician, not good with my units. Right. Okay. This one was challenging. So just remember, I used, how did I come up with these numbers? Just once again, really quick. I used the side measurements to find the area of the square, right? That was my first step. The first step was to find the area of the square, right? And I used the side measurements, 10 times 10, in order to do so, right? If we are punching out a hole in this square, all we're doing is the area of the square minus the area of the circle, right? So that tells me, well, I need to find the area of the circle next. So that's what I did. Found the area of the circle next. I said 25 times pi is approximately 79. Right, approximately 79. And I said, okay, we'll do 100 minus that 25 pi, which we approximated to be 79, right? 25 pi, it's all the same. We just said, we'll just make it about 79. So 100 minus 79, it's 21. So that's about, right? Approximately. It's a tough one. Okay. In the right triangle below. Ooh, these are tough. The value of x is approximately how many feet? Okay, so we're going to use the Pythagorean formula for this one. Pythagorean formula states that, I should say the theorem, a squared plus b squared equals c squared, where a and b are legs of the right triangle and c is the hypotenuse. Right, so let's just replace these values with what we have here, right? So a is 5 squared. A is 5, b is 6, and c is x in this scenario, solving for x. This one's not too bad. I know that 5 squared is 5 times 5, which is 25. I know that 6 squared is 36, 6 times 6. And x squared, we're not sure yet. 25 plus 36 is, that's the same as 56 plus 5, which would be 61. Ugh, this is going to be a gross one. Okay, so let me break out my calculator. So what would we say? 25 plus 36, right? Let's check my work. 61. All right, let's find the square root, right? So you're probably looking at this and you're saying, oh, geez, what do I do now? Well, you have to find the square root of both sides because we're looking for just x, right? And another way to think about square roots is that they get rid of that square right there. Right? That's one way to think about them. It's not perfectly accurate, but it works for us. So we'll take the square root of both sides, and like I said, they just get rid of this guy right here. So we'll just be left with x on the right-hand side, and the square root of 61, ugh, it's going to be gross, trust. 61 is a prime number, so we'll take the square root of 61 on your calculator. You get about 7.8. Say approximately 7.8. And then I'm looking at my answer choices, and I'm saying, I don't see 7.8 here, right? Ugh. Well, isn't seven? If you had $7.80, you have about $8, right? Let's see. So which one's closest? Right. There's that word again, approximately, right? Okay. During the past 3 days, Janet ran 12 miles of a 76-mile run. How long will it take for Janet to finish the run? So during the past 3 days, this is a strange problem. Janet ran 12 miles. I think we're going to have to set up a proportion. Okay. So we know that, we know that she's ran 12 out of the 76. Okay, let's use some different colors here. And I know we know that it took her 3 days to run the 12. How long will it take her to run the rest? We don't know. We don't know the total, right? Not sure. So we set up this proportion. There's a lot of algebra under the hood here, but we can use this method that we call cross multiplication, right? And what that allows us to do is to make a very simple statement. It allows us to say, well, 12 times x is going to be equal to 3 times 76, which I know is going to be 3 times 6 is 18. We're going to carry the 1. 3 times 7 is 21. 228. All right, where did that 228 come from? It came from 3 times 76. Right. So, in essence, we have 12x equals 228. All right. I'm too lazy to do the math in my head, but how do we solve for x? Well, we need to get this x on its own, right? So let's divide both sides by 12. 12s are going to cancel out. X is going to be equal to 228 divided by 12. Ooh, nice even number. Yay. 19 days. 19 days total should be the time it takes for her to run. Use the triangle below to answer questions 17 and 18. Oof. Alright, let's give this one a try. I'm assuming that they mean the area of the large triangle. There's a couple ways we can do this. Think of this as... I have to make a couple of assumptions that I'm not totally sure are correct. No, I think they're pretty fair assumptions. But I'm going to make them nonetheless. I'm sure I can justify them, but at the moment I'm just going to be kind of assuming things. Well, I'm assuming that this altitude is the end point. I'm sorry, not the end point, the midpoint. So that would mean that we actually have two segments right here that are both 4 meters long. Okay. 4 meters long. Now, here's what I'm going to do. I'm going to find the area of the whole triangle by finding the area of both of these, of basically doubling the area of this triangle. Because what ends up happening here is that under my assumptions, uh, these two triangles, the blue and the green triangle, are actually the same. They're congruent. So I can actually just find the area of one, right? So the area of big triangle is going to be equal to the area, 2 times the area, 2 times the area of, let me get rid of this over here, of the blue triangle. Right. Okay. So the area of the big triangle is equal to 2 times the area of the blue triangle. And my justification for that is that the blue triangle and the green triangle are actually the same, right? So this is very unmathematical, but the blue triangle is the same as the green triangle. Right, that's where my assumption's coming from. So let's find the area of our blue triangle. I know that my area is going to be 1/2 times base times height. I know that my base is 4. So 2 times 1/2 times 4, and my height is 5. So arithmetic, one cool thing that we can actually do is we can actually just distribute that 2 to that 1/2, right? And these are actually going to cancel each other out. So all we're left with is 4 times 5. There's a lot of ways to do that problem. You can just throw it in your calculator, honestly. 1/2 of 4 is 2. 2 times 5 is 10. And then 2 times that 10 is 20. There's a lot of ways. We get 20 square meters. The perimeter, ooh, that one's a little bit easier actually. The perimeter is just the area around, right? So I know that each side is, I know that 7, I know there's another 7, and I know there's an 8. So 7 plus 7 is 14. 14 plus 8 is 22. Perimeter is actually a one-dimensional measurement. That's why it's just the regular meters, right? And area is a two-dimensional, right? Length times height. Okay. This is pretty difficult, man. There's a lot of problems. $19's not too bad. You can just use a calculator for that. So what was it? 5.18 times 0.52. You get 2.6936. Honestly, you probably didn't even need a calculator for that. One way that you can think about that is 5.18. 0.52 is very close. It's very close to 0.5, which is 1/2. So you can kind of think of that as what's 1/2 of 5? That gives us about 2.5, right? This is very much an approximation. We can approximate. It's about 2.5-ish, right? And none of these are even close to 2.5, right? They're all off by at least a factor of 10. Again, this one's pretty simple. You just need a calculator. So actually, let me do it like this so I can see. 56,456.12. Oops, sorry. Minus 3,564.08. and 52,892.04. Just like that. Again, you could probably approximate. A lot of these answers are very off. Actually, no. A is pretty close. Tony wants to fence his yard. The dimensions are as follows. What is the perimeter of the yard? Perimeter is simple, right? All you need to do is add them all together. So 10 plus 7 plus 4 plus 2, 13, 23. That comes out of 23. Using the figure in number 22, what is the area? Ooh. That's tough. Not impossible, though. I'm going to break this up into two rectangles. Like this. Just remember that this length is 2. That's going to come in handy later, okay? So I'm going to find the area of this rectangle like so. And then I will find the area of the blue rectangle. Okay. All right, so let's find the area of the green rectangle. This is for number 23. So the area of the green rectangle is 7 times 2, which is just 14. The area of the blue rectangle. Okay, this one's actually where it gets a little bit difficult. The blue rectangle cuts off right here, right? But the 10 is that entire length, right? So how do we find just this length? How do we find just this length right here? Well, it's not hard as far as calculation goes. I know that it's going to be 10 minus that 2. So that's going to be 8 feet. So how did I get 8? It's the whole thing minus that 2 right there, right? So area of the blue rectangle is 4 times 8, again, just length times width, right? Length times width of the blue rectangle, which is 32, and then we're going to add these two numbers together. 14 plus 32 equals, why can't I think today? 46? 46 for square feet. Answer should be B. The selling price of an item, is 25% above the cost of goods to the vendor. There's an 8% discount for cash payments. I don't know what to think about this one. Oh, maybe it's not as hard as I thought. Well, if we're making a 25% profit, if we're making a 25% profit, and then 8% discount for cash payments, well, 25% minus 8% is just 17%. I believe that's actually just, I think I'm right, but that's one I'm just not completely sure on. Let's double check. That was number 24, yeah. 24 was C, is that what I put? Yes, okay, cool. Okay. 25 is the same exact problem. 25 is the exact same problem. 20% profit minus the 10% cash discount. It's just a 10% profit. Okay. So using the graph below, the slope of the line is 1 over 4. Remember, that's rise over run. So our rise over run in this case is 1 over 4. What is the length of line y? So we're looking for this guy right here. Looking for the length of this. Ooh, that's difficult. Let's think. Oh, it's not too bad. I know that one way to think about this is that y over 8 is going to be proportional to 1 over 4. Kind of like this. Let's see if I can get this perfectly correct. So I know that for every 4 units I go to the right, I go 1 up, right? That's what that 4 over 1 means. Or I'm sorry, the 1 over 4 means. So the 1 over 4 means for every 4 units I move to the right, I have to go 1 unit up. Right? So what if I went 8 units to the right? Well, that means I would have to go 2 up. You could reason it out like that. You could do some cross multiplication. So y times 4 is 4y. Y is going to be 2. Divide both sides by 4. Divide both sides by 4. Y equals 2. All right, so I set up my proportion. At the heart of it is that think of it like stairs. Maybe you're taking some really shallow is not the right word, but not steep stairs. For every 4 steps that you take, you move 1 up, 1 foot up. Well, if you took 8 steps, you'd be 2 feet up the stairs. Okay? So y in this case is 2. Absolute value. So all absolute value does is really get rid of negatives, right? So in reality, what we would do here is that there's a scenario where y is positive 5, or y could have also been negative 5, right? Because remember, when we take the absolute value of y, it gets rid of this negative right here, right? So there's a possibility that y could have been positive or it could have been negative, right? I could show you on a graph. All right, so if I did the absolute value of x, like I said, there's a world where it's positive and positive, and a world where when we take the absolute value of negative 2, we get 2, right? So pretty much all it does really is get rid of the negative sign. So we kind of have to just split this up into 2 cases. Well, there's a case where this whole equation was positive 7, and there's a world where this was negative 7. Okay, so all we have to do is 2 algebra problems, right? So 7 minus 7 on both sides. 7's cancel out. I'm silly, sorry, I messed this one up. It's not 7, it's 3. 2y plus 3, sorry about that. So we'll actually subtract 3 from both sides. The 3's cancel out. I'm left with 2y on the left-hand side. 7 minus 3 is 4. Divide both sides by 2. 2's cancel out. I'm left with y equals positive 2. So that's one of our answers. Same thing here. Subtract 3 from both sides. 3's cancel out. That's why we did it. We're left with 2y on the left-hand side. Negative 7 minus 3 is negative 10. I'm going to divide both sides by 2. Y equals negative 10 divided by 2 is negative 5. So negative 5 and positive 2. This is a really bad format for an answer. I don't know why they put it like this. That implies that there's some sort of ordered pair when in reality it should look like this. Right? This is the set of possible solutions. So I don't know why they put it like this. It's very silly, but whatever. What do I know? Sure, the people that made this test are getting paid more than me, so. All right. So assume y is an integer. Same thing. So we have two worlds here. There's a world where y minus 2 was positive 4. This one's easier. Negative 4. So just algebra. Add 2 to both sides to get y on its own. Here y equals 6. Add 2 to both sides. Y equals negative 2. So it could be positive 6 or negative 2. So notice on number 30, notice how this is actually all the same on the left-hand side. So the left-hand side didn't change at all. This all stays the same. So don't really have to do anything over there. This is really just a distribution problem. So 5 minus 3x, not important. We don't care about that. 6 times 4 is 24. Don't forget the x. And 6 times 2 is 12. And so this is really what we're looking for. 24x plus 12. Yep, there's our answer, D. So it's really just a distributive property. For number 31, this is a cross multiplication thing. Looks pretty complicated, but it's not too bad. I know that x times 5 is 5x. So I can cross out b and c. And 12 times x minus 2 should look like this. Not quite there yet. Again, we can already probably cancel. I know the answer is A, but let's get our answer to look exactly like it. So I'm going to distribute that 12 to both sides, or to both terms, I should say. 12 times x is 12x. 12 times minus 2 is minus 24. So 12x minus 24 equals 5x. And they just did a little bit of symmetric property, switching the things around. The x-intercept is the point where the line crosses the x-axis. What are the coordinates of the x-intercept of the line? 3x plus 5y equals 15. This is pretty simple to explain. So basically you have, in any equation, well, not any equation, but in some equations, graphs, functions, relations, you might have what we call an x-intercept. And the x-intercept is simply going to be, again, this could look like anything. It could be a curve, it could be a line, right? Might be a line. In this case, it is a line, right? I don't know what it looks like, but the x-intercept is just going to be this area right here where we cross the x-axis. I could use graphing software to show you, so I'll do that when we're done with this problem. So how do we solve for the x-intercept? Well, what we're going to do is we're actually going to set y equals to 0. So set y equal to 0. I'll explain why in a bit. But when we set y equal to 0, well, 5 times 0 just cancels out. We're left with 3x plus essentially 0, right? So let's just leave it out. Equals 15. And we see that x equals 5, right? When we divide both sides by 3. So now we have a situation where x equals 5 and our y was 0, like we just said. So that is our answer. So let me explain what's happening here. 3x plus 5y equals, was it 15? Was it 15? Yeah. And if we scooch over here, here's our x-intercept at 5, 0. So why did we set y equal to 0? Well, if we're crossing this x-axis, if we're crossing this x-axis, notice that we're not up or down at all. We're right on the axis. So it's, you could say that we're 0 above or below the x-axis. So that's why we set that equal to 0. If negative, this is just algebra, simple algebra. Negative 8x equals 24. Let's divide both sides by negative 8 to get our x alone. The negatives cancel out as well. 24 divided by negative 8 is simply negative 3. So let's simplify by combining our like terms. There's our x terms. There's our z terms. So think of this as 2x minus 8x plus 4z minus 1z. 2x minus 8x, well, that's just going to be negative 6x. 4z minus 1z is simply going to be 3z. So negative 6x plus 3z. Choose the best estimate of 8.6 times 21. I'm gonna do a couple things here. I'm gonna round that 21 down. I'm gonna round that down to 20. And what that's gonna allow me to do is think of this as 8.6. Sorry, I messed this one up. 8.6 times 10 times 2, just using the associative property there. And what that allows me to do is say that it's approximately 86 times 2, which should give me about, what, 160 ish, whatever, 162. Okay, yeah, about that. Nothing's even close, right? I'm estimating 2. How many inches are in 1 yard? Well, I know that 1 yard is 3 feet, right? And if I know that if 1 foot is 12 inches, well, 1 yard is equal to 3 times 1 foot, which is really 12 inches, right? And so 1 yard is 3 times 12 inches. That's going to be 36 inches, right? So 12 inches in a foot, 3 feet in a yard, 1 yard is 36 inches. Exponents, fun. Think of g to the 5th power. Think of it like this. Think of g to the 2nd power like this. Now what we can do is we can cancel this out. We're actually left with 3g on top, or g, g to the 3rd power on top. Another way you could think of this as g to the 5th times g to the negative 2. And that's g to the 5 minus 2, which is just g to the 3rd power. So same thing, same way, two different, same answer, two different ways. Julie made a fifth of the cupcakes at a bake sale. There were 35 cupcakes on the table. How many did she make? What's 1/5 of 35? You can think of that as 35 divided by 5, which is just 7. Think of 1/5 times 30, 1/5 of 35 like that, and then just throw that 35 on top. 35 times 1 is 35, and that's how I got that. Ooh, this is gross. The first thing I'm going to do here is I'm going to convert this mixed number to an improper fraction. 5 times 1 is 5, plus 2 is 7 over 5, plus 2/3. Now I need common denominators, so I'm going to multiply both top and bottom over here by 3 over 3. That's just 1, right? Plus 2/3, I'm going to multiply by 5 over 5. Again, that's just 1. 21 over 15 plus 10 over 15. That gives me 31 over 15. And they want us to change that into a mixed number. 15 goes into 31 twice with a remainder of 1. Our answer is A. So how do we get from here to here? I said 15. 15 times 2 is 30. But we're talking about 31, so there's that 1 left over. Tom's financial advisor recommends he put $80 per week in his saving plan. This is 40% of the amount he earns weekly. What does he earn? So what is, how much does he earn per week? We'll call that X. And I know that 40% of that X, let me write it like this. I know 40% of that is 80. So think of 40%. Think of that as 40 out of 100 times X. Now we have a pretty straightforward algebra problem. Let me simplify this fraction to make it even easier. All right, so that's 40% right here. I'm going to cross off some zeros. I'm going to simplify to, I can divide both of these by 2. So how do I get rid of a fraction with algebra? I'm going to flip the fraction and multiply. All right, obviously over here these cancel out. I'm left with X on the left hand side. 80 divided by 2 is 40. All right, 80 divided by 2 is 40 times 5 is 200. He makes 200 a week. This one's just going to be a pain. Y times Y times Y times Y times Y is Y times Y times Y times Y. There's Y to the 6th. There's Y to the 3rd. How many Y's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Y to the 9th. The following graph represents the monthly car budget. If Sally budgets $1,400 per month for her car, how much does she pay in registration? Okay, so 25% is a quarter, right? Right, 25% is 1/4. Right, so 1/4 of that 1,400. That's really just 1,400 divided by 4. I don't know if you're allowed to use a calculator on these. That's 700 divided by 2, which is 350. C. She pays $350 in registration. Must live in California. Luis drove 350 miles from San Francisco to Reno in 4 hours 15 minutes. Which of the following computations is used to obtain Luis's average speed in miles per hour? Oh, that's easy. 350 miles divided by, 4 hours and 15 minutes. Well, isn't 15 minutes a quarter of an hour, right? Quarter after. So 4 and 1/4. 4.25 hours. So divide. All right, not too bad. So yeah, I think that might be it. Just let me know if you got any questions, all right?